All right, so hopefully everybody had a good time, I guess, with the midterm. We'll have those graded hopefully early next week along with your last hack. You still remember have a hack this week, even though you didn't have a lab yesterday. That hack is due on Monday as usual, but there's only a C version, remember. You've already been given credit for the Java version, okay? So today what we're going to do is move on to the next topic, which is file I/O. It's pretty simple. You already have an idea of what files are. A file is just simply a unit of memory that is stored usually on disk, but of course it can be stored in memory. Let me make sure that my mic is... Yep, all right. So remember that we are on Piazza, we are on YouTube, so if you have any questions, please go ahead and post there. Otherwise, again, it's usually on disk, but it doesn't have to be. And in a Unix-based system, everything is a file. Directories are files. Programs are files. Why? Because they're just a chunk of code that's sitting somewhere on the disk until you execute the program, and now it's living in memory, right? Sockets are files. So what are sockets? When you need to open up a connection from one computer to another computer, right, in order to communicate and send data back and forth, you open up a socket on a network, a TCP/IP network. Well, how do you get information from one computer to another computer? You treat that socket as a file, and you do file output to send it over to the other computer. You do file input to receive it from another computer, right? So sockets are files. Files are files, of course, and also, or buffers, right? Buffers are files, right? When you mash your keyboard, and you put data into the standard input, that's a buffer. You're writing to a file. When I type ABCDE, that is being written to a file, and then your program, whenever you have like a scanf function or something like that, will start to read from that file. So file input streams, the standard input, the standard output, those are files as well, right? Usually files are stored on disk for long-term persistence, right, of data. Now, persistence here is something that we'll talk about later, and especially next semester with databases. You want data to persist from the run of one program to another program, right? You don't want data to die. And so you need a way of storing that data between runs of your program or between runs of different programs. And that's called persistence, right? You can read, that is input, or write, that is output, a file, right? Files may be plain text or binary files, right? For example, just plain old text like hello world. Here, I've got an example over here. Here's a file where I put hello world, how are you, and then a bunch of numbers in there. That's plain text, that's human readable, okay? You can also have files that are not necessarily meant to be human readable. Binary files, right? Image files, audio files, those are all binary files that you would have to open up with another program in order to interpret that data as a sound or as an image and display it on the screen. So it could be plain text or binary files. We're going to focus mostly on plain text files because if you're dealing with binary files, you bring in a library, right? The library that you use to do image manipulation, for example. We didn't have to write that from scratch. We just brought in the library to take care of that binary data for us, right? So binary data, they may be intended for human consumption or not, right? For example, if I just wrote an email message and put it, hello world, how are you? This is intended for human consumption because you can actually read it. There are data formats that are not necessarily intended for other humans to read. One of them that you're already familiar with is CSV files, right? Now this is definitely human readable, and we can go line by line here and we can read and understand these things, but this is not a format that is intended for a human, right? If you wanted this nicely formatted for a human, you would put it into like a web page table or something like that, tabular data, right? You wouldn't present it to a human like this. Other formats, the CSV is not that great. Other formats that basically have the exact same data here, but in a more computer-friendly version of it, would be JSON. Right? This is JavaScript object notation. And you can kind of see here that this is the beginning of an array. And then each book is represented by an object with opening and closing curly brackets, separated by commas. And then these are called key value pairs. So this course, and the course is associated with this CSCE 155A or whatever, right? The title is this string over here. The author is this string over here, etc. Right? So this is another way of representing the same data, but in a more computer-friendly version of it, right? And now what I can do is I can bring in a library that is able to read and understand JSON formatting, and I don't have to do any of the file input output directly. I can read it in from a JSON file, manipulate, process my data, whatever, dump it to another JSON file. Another one would be XML, right? And you'll be working with this eventually in your next lab next week, whereby you have these tags, Langle, Wrangle, and then you have tags, and within that you've got basically a hierarchy. We've got these books, and under that we've got book, 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 book. Under that we've got course, title, author, etc. So it forms a hierarchy of data, and these tags here are basically metadata. It is tagging this string right here with semantic meaning, that this is the course. And how do I know when the course ends? Well, this closing tag here with this forward slash, excuse me, and then it closes the tag up here. You can get really, really super complicated on this if you really want to, but this is the exact same data as presented here, here, and here with 3 different formats, right, that are all intended for computer consumption, okay? Again, if you were to intend this for human consumption, you'd put it in a nicely formatted table or Excel file or something like that. Those standards are more for EDI. Right? EDI is electronic data interchange. So, for example, if you want to send data from one computer to another, where that computer is running Java, but the receiving computer is running something completely different, Ruby or something like that. And you need an data interchange format, something that both programs would understand even though they're not written in the same language. You want a data format that is independent of your actual language. And so XML, JSON, or Base64 encodings are the de facto standards. Right? Base64 encoding is just a way of taking a binary file, expressing it using plain text. So it's Base64 because it uses A through Z, uppercase and lowercase, that's 52, and then it uses 0 through 9, so that's 62, and we need 2 more, and I forget what the other 2 symbols it uses, but you can take a file, an image file, send it over email, for example. Email is 100% text-based. You don't actually send binary data over email. What it does is it encodes it, UU encoding, say Base64 or something like that. And then it sends that text encoding, and that text encoding is decoded back into binary at the other end. Right? All right, so electronic data interchange. Again, we're going to focus mostly on plain text files because that's the easiest to do. If you are doing EDI, even with XML, JSON, certainly with binary files, pull in a library to do it for you. Right? The basic steps to file I/O, though, are you got to open the file, you got to process the file, reading or writing, whatever you're going to do. And then 3, you've got to close the file. So how are we going to do this in C? File I/O in C. We're going to go in a step-by-step process here. We're going to look at the easy things first. So in C, files are represented with a built-in pointer. It's not built-in, but it's in the standard library, I believe, standard input-output library, with a pointer type. Right? File, and then star. And that is all uppercase F-I-L-E. Right? And the star indicates that it is indeed a pointer. Why? Because when you open up a file, it initially points to the beginning of the file. As you read either line by line or character by character, that pointer, just like my cursor here, advances. If I read C-O-U-R-S-E, the pointer now advances as you read it. Right? And then eventually it points to, at the very end of the file, it points to the end of the file. That's how you know that you're done processing the file. Okay? So it uses a, not built-in, but a pointer type, because it's pointing to somewhere in memory. Whether or not it's on disk or whether or not it's in main memory, it doesn't matter. It's a pointer to a memory location. Right? To open a file, you use open. What do you think that stands for? What do you think the F stands for? File, right? So file open. It takes two parameters. The first one is a string representing the path plus the file name to open. Right? The second is the mode. So for the mode that you open it in. Now there are several supported modes here, but we're only going to focus on two. R or W. Right? What do you think the R stands for? Read, exactly. So reading is going to be file input, right? Reading, file input. And W, the other R, right? You know, the three R's. What's that going to be? Writing, that is file output, okay? If successful, it returns a valid pointer. If unsuccessful, what do you think it returns? Remember, it's returning a file pointer. So what's the only thing it can return if it fails? Null. It returns null. Now, oops, capital N. Give me a circumstance in which you think opening up a file might fail. It's corrupted, so I could still open it and look at garbage, right? So I could still, it would probably still succeed. It's just that when I go to read a line and I have one expectation, but that it's corrupted, then my program's going to fail some other way. Doesn't exist. Huh? What else? So I gave it the wrong path, so I would say that's the same as doesn't exist. Not the right type, so there again, it's probably more of corruption there. Think about a password file. Should I just willy-nilly be able to open up the password file? Don't have access. Don't have permissions, right? What else? You don't have the permissions. You don't. It doesn't exist. There's one more that I was thinking about. I forget. But no. Okay, that's good enough. All right. So let's go ahead and try an example over here. Right? First of all, I'm going to find out if they have an Etsy password file. They do have an Etsy password file. So note here what I was doing is I'm listing the Etsy, that's etc. Password, PASSWD, that's the password file. Passwords aren't actually stored in the password file, right? That's legacy. That's a legacy name. The root password here has been redacted. It used to be stored right there where that X is. It's no longer stored there. Instead, it's so I can read it, right? I can read the Etsy password file, right, just fine. But can I actually? The actual passwords are stored in an Etsy shadow file. Shadow. There it is. Shadow. Right. And so, do you think I should have access to that? I don't think I do. Cannot open it. Permission denied. So let's go ahead and try to open it up and see if that works. So I'm going to go ahead and create a file pointer here. I'll just call it F. Right? I'll call open, and I want to open up that Etsy password file, right, for reading. Do you think I should be able to write to that, by the way? Probably not. I probably have permissions to LSLA, Etsy password. Yeah, I have permissions to read it, but I do not have permissions to write to it. W here would be write, but that's the super user. The root has permissions to read and write, but I only have permission to read right here. Yeah?
Is file like a struct within?
It's a macro, I'm sure, and it's probably just a generic pointer of some sort. You'd have to look at the actual underlying code, but that's what we're going to use. It's probably system dependent. That's why it's all uppercase like that. It's probably just some macro that, however that operating system handles files, that's the type of pointer. All right, let's check to see if it worked. If f is not equal to null, equals null, then I'll say printf unable to open file. Okay, there we go. Else, just making sure that it works. Else, I am able opened file successfully. And the line, there we go. All right. Let's go ahead and compile this and run it. I should be able to open up the etc password file for reading. Should I be able to open it up for writing? Probably not. Let's go ahead and find out. Right. Unable to open file. Now what about that etc shadow file? Should I be able to open that up for reading? Oops. Let's go ahead and compile it again. And unable to open file. Good. All right. All right, let's go ahead and open up a different file here. Right? mydata.txt. Now note here that I'm not putting in a path. So where is mydata.txt going to end up being if I open it up for reading or writing, for that matter? In the same path, exactly. That's equivalent to doing // right? When you run a.out, /a.out, you are running the a.out file in the current working directory. Likewise, if I save just a file name here, it's going to be in the current working directory. You can put in a full path if you want to. Full path to some other file, right? That's that starts at the very top of the directory structure, right? Not even up here, but ls up there, right, where you shouldn't be lurking anyway, or where you shouldn't be. You can have a relative paths. So if you go up one directory, it's .. and then /mydata. Right? If you want to, you can go up one directory and then down another directory, files /mydata. That's called a relative path. You go up one level and then over to a different directory and then down that level. Right? Okay, I'm just going to open this up for reading in the current working directory here though. Let's see if it fails or not. Unable to open a file, why? It doesn't exist. Right? But what if I open it up for writing in the current working directory? Does it have to exist if I'm going to write to it? Nope. It would open the file successfully. In fact, as you see that over here, it now exists. Of course, there's nothing in it because I didn't write anything to it. Right? So let me go ahead and blah, blah, blah. Right, there we go. Now I've actually typed something in that file. Let me close it and recompile this program and then run the program again here and see what happens to that file. Open the file for writing successfully. What do you think the contents of that file is right now then? There was blah, blah, blah in there before. Then my program opened it up for writing, didn't write anything, blah, 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 didn't write anything, and then it ended. Let's find out. What happened to that blah, blah, blah? It's gone because you overwrote the file by running this program again. Right? You have to be very, very careful. If you open up a file and start writing to it, you will overwrite whatever was there before. There is no undo. There is no undelete. Right? There is no saving you from yourself if you have bad file I/O. Right? Okay, well, I'll put in a to-do here. Actually do something with the file, ... But before I do that, let's take care of the other easy part. So step 1, step 2, step 3. Open the file. Process the file, either read or write to it. Close the file. So how do I close a file? If fopen opens a file, what do you think closes a file? For close. And I need to pass in the pointer so that it actually closes. If you don't close a file, 99 times out of 100, the operating system will save you from yourself. It's that 1% of the time that you don't close the file, there's still something left in the buffer that doesn't get flushed back out to the file, in which case your file ends up being corrupted. It could, the entire file may be blown away. It might be incomplete. It might be, the contents might be corrupted somehow, et cetera, et cetera. But failure to close the file is probably, I don't think it's undefined behavior, but it's certainly not good practice. Right? And sometimes it will destroy your data. So be careful. Right? All right, so here are some more examples. I'll just go ahead and copy paste. You open up a data file in the current working directory by not providing any path. You can provide a relative path to go up two levels, down over into my data, and then input.txt. You can have absolute paths here if you start at the beginning of the root of the file system. And of course, it can fail. You're not allowed to open up that Etsy shadow file for reading, right, or writing. Right? You cannot read those passwords. That's a good thing, right? It used to be that they gave you sudo access here. Sudo. Does anybody know what sudo is? Super user do this for me. Right? So it's going to run as root here. Sudo more Etsy shadow. And of course, I'm not in the sudo group, users group, so I don't know what the password is. They're not going to let you do that. The password used to be Ubuntu, but they got rid of it. This is why you can't install your own packages either. And I had to get them to install a bunch of stuff for us this year. Okay. All right. Let's see. And then, of course, closing a file. Failure to close a file may result in corrupted data. There we go. And all you have to do is go fclose or fclose. And that's it. So, reading and writing a file. File output is probably the easiest thing to do here. So, there are lots of ways of doing this. There are many ways of doing file output. Let's keep it simple. Keep it simple. Stupid. I'm not calling anybody stupid, it's just the same, right? Use something that you're already familiar with. fprintf. Right? You might not be familiar with fprintf, but certainly you're familiar with printf. What do you think that F in the front stands for? File printf, right? It has the exact same behavior. It has the same behavior as printf, right? But with one additional argument. The file you want to print to. Right? Instead of printing to the standard output, you provided a file pointer and it'll end up outputting to that file. So let's go ahead and let's actually do something with that file, my data. So normally if I wanted to print something to it, I would print hello world using printf. To do this with file fprintf, you just put f in front of it, and then the file that you want to print to. In this case, it's f. Right? It is not the file name. You already provided the file name when you opened it. This is sometimes called a file handle. So a lot of tutorials will use h instead of f because it's short for handle. Also EF, G, H. Yeah, they skipped G, I guess. But I'm going to go ahead and stick with f here. And then I've successfully closed it. If you've got other things that you need to format, int, x is equal to 42, f printf, I don't know, f, and then x is equal to %d, tab over if you want to, pi is equal to %f, and then I'll go ahead and put in x and m pi. I brought in the math library, right? No, I didn't. So include the math.h. There we go. And then end the line. There. If I run this, you see that my data, of course, existed before, but whatever was in there before has been overwritten. So reload it. Right, there we go. Hello world, x is equal to 42. There is indeed a tab over right there. Right? And pi is equal to the default formatting here. All right? Printf. Doesn't get any simpler than that. Yeah?
Probably a dumb question, but you can only write to the file if you open it with the W argument, right?
You can use, it is indeed a string. So you can open it for, there's also a for appending, and that jumps to the, I believe that jumps immediately to the end and start writing there. You can open it up for reading and writing at the same time if you want to. I wouldn't recommend doing that because now you're doing a lot of bookkeeping. Basically, this pointer here is pointing to the beginning of the file at the beginning. You can advance the pointer, you can fast forward it, and in fact, it's called seek, right? It's like a tape. In fact, these words come from the old school computers where they had tape storage instead of disk storage. And so you could seek and go forward. You could rewind and go backwards, right? Anywhere in the file. So you could jump to the 5th line, start writing the 5th line, and then skip to this 8th line and start reading the 8th line. You know, you could do anything you want. I want to keep it simple though, right? So yes, you can do whatever you want with the file. It's just a pointer. So it's just memory. You can do whatever the hell you want with memory.
So I guess my question is, if I open up the file with and read only, I wouldn't be able to use that printf.
I don't think so. Let's find out. That's a good question though. For reading, and then if I try to write to it, I'm probably undefined behavior. Yeah, segmentation fault. Right? Why was I unable to open the file? Oh, no. All right, so I was writing to it before. I wanted to read from it now, but if I try to write to it, so maybe not segment, yeah, open successfully. You can see it over here. Looks like it didn't do anything bad to it, but that's just because, yeah, it sheepishly refused to execute these. Oh, I don't know if it refused or not. Let's go ahead and make sure that we're actually doing something different. And open the file successfully. Let's see if it's that garbage now. No, it's not. So I open it up for reading only. You cannot write. Looks like writing to it, if you do that, is a no operation. That's what it appears to me here. Yeah. This right here? Yep, you're passing in the pointer here. And it is by reference, so you don't need to dereference it or ampersand it or anything. Yeah?
Is it possible to make a file openable by some files but inaccessible by others?
Oh, yeah, well, that's a system level thing. So LSLA is going to list all of the metadata with respect to these files. And you can see right here, these first 3 are read, write, or execute for the person who owns it. The person who owns it is me, Ubuntu. I'm Ubuntu right now because that's my username. Who am I? I'm Ubuntu, right? So I own it, so I can read and write it, but anybody else on the system would not be able to read or write it because those 3 permissions have been set to nothing. The next 3 permissions, that's group permissions, and then this is individual permissions. So if I wanted to, I could set it to, chmod is change mode, change the mode of permissions basically of a file. And I can go ahead and go 755, right? And we'll see what that does here in a second. My data, there we go. LSLA, my data. And you can see how I've changed it here. 755 were decimal representations of 3-bit binary strings. 7 is going to be 111. So I've changed it to read, write, and execute. I gave myself permission to do that. The next one is 101, which corresponds to 5. That was 755. And so I've given the entire group, Ubuntu group here, permission to read and execute, but not write to it. This one, I can go ahead and just give write permission to if I want to. 754. And you see here 4 in binary is 100, right? And I've given read permission, but I've not given write or execute permission. That's a system level thing. That's a Unix thing. Right? You can set permissions, I believe, like programmatically, but you generally don't. Let me go ahead and change. I don't need to change that back. I can just go ahead and remove the file entirely if I want to. Yes. And then run a.out. Okay, a segmentation fault. Why? Because it doesn't exist, right? I want to open up for writing. There we go. There. Now it's back, and it's got that message I was doing before. Okay. Oh! Idiot. So in an IDE, usually, well, in most programs, if you go Command W or Alt W, it closes the current tab. Well, I'm within a program, and so closing your tab is not that easy. You have to actually manually close that. So sometimes I'll screw up and I'll close out the entire browser by closing out the tab. Right? All right. So back over here. So if you want to print things out, just use fprintf if you want to output to a file. There's some more examples there. All right, so it's also some notes. If you open it up an existing file and start writing to it, it will start overwriting everything in that file. Right? This is referred to as clobbering it. Maybe I've mentioned it before, clobbering. Right? You're overwriting a file. Where does that come from? I don't know if it comes from like the thing, Marvel, what is it, Fantastic Four, right? The Thing, and he clobbers things. I'm sure that the word existed way before that. I'm sure. I don't know if they took it from that comic book or not, but in any case, that's what's known as clobbering. You're clobbering the file, you are overwriting it, and losing the original data. There is no undo, there is no delete. So be careful. Right? And by the way, you can open up your source file accidentally, start writing to it, and guess what happened to all your code? Bye-bye. Right? Right? Demo.c. What's going to happen here? I start writing. Oh, I didn't mean to open up my own source file. But if I do, aha. Bye-bye code. Right? Starting over. Undo. There is an undo as far as the text is concerned here. Right? And definitely undo that. There we go. So, be careful. File input. Again, there are several ways of doing file input. Right? We're going to restrict ourselves to the most, in fact, are dangerous. Because they're susceptible to buffer overflows and buffer overruns. You don't want to arbitrarily, do things with memory. So what I'm going to do is I'm going to show you the two safest, easiest ways of doing things. We're going to look at two safe, easy ways. fgetc and fgetS, or fgetc for short, and then forgets on the second one. As you might predict, the F in the front of those is for file. Get, you're getting something, you are inputting something, you're reading something. What do you think that the C and the S stand for, though? Character and string, right? So, each one reads either a character or a string. In fact, the way that it does a string is a line of the file, one at a time, advancing the pointer through the file until the EOF symbol is encountered. EOF, what do you think that stands for? End of file. And it's a special symbol. It is not in the ASCII text table. Usually it's -1. It's just an integer flag telling you that it's not a regular character. It's just this special character that indicates the end of the file. Don't try to use anything else other than EOF, okay? All right, let's go ahead and open up a file for reading. And remember that I had my data here, okay? That's what it looks like. Or we could do File, .txt. Yeah, let's do file.txt. Stop doing quick keys. Thankfully, it opens back up quickly. All right, there we go. File.txt. All right, we'll open it up for reading. And instead of writing to it, we'll go ahead and get some characters. So, f get c of f. Let's get the first character. And let's print it out. C is equal to percent %C and the line, and then we'll print out C. Okay. Let's get the second character. And the third character. And the fourth character, and the fifth character. Right? And we see hello. Right? That's kind of tedious doing it character by character. Certainly, if I copy pasta like I just did. Yeah.
So every time you call f@c, it moves the pointer.
It moves it forward one. You read the first character, next character, next character, next character. Now again, there are other functions that we're not going to cover that allow you to forward seek or rewind the tape in the file so that you can go back and forth if you really want to. We're going to keep it simple. Right? One way only. Okay. So I don't want to copy pasta. What should I do instead? A loop. What kind of loop? For loop or while loop? A while. Why did you say while? What about a for loop? For each character in the file. Do I know how many characters there are up front? Nope. What you could do is you could go through the file once. Actually, you could use seek, and it'll advance it all the way to the end, and I think it'll tell you how many bytes it actually read. But in any case, you can go through it once and then rewind it, and then you know how many characters there are, but you had to go through it once to begin with. Right? Yeah?
Can you find the length of the file? String?
Nope, not as a string, nope. In fact, what you'll find in your hack next week is that you will write a convenience function to simply just load up the entire file into one string and be done with it. You'll write that functionality. All right, so I don't like a for loop either. While C is not at the end of the file yet. While it's not equal to EOF, then go ahead and print it out and get the next character, setting yourself up for the next iteration of that loop. Okay, yeah?
How do we know what EOF is?
How do we know what?
What EOF is?
EOF is just the end of file. It's just this special symbol that is defined in the standard input-output library. Right? It's built in. It's not built in, but it's there for you.
How do you know if it's like the correct file that it's looking at?
Well, you opened it up. You would have had to open it up.
Yeah.
And if it was not the correct file, if it was unsuccessful, then it's null, right? And you could handle that like by quitting, right? There's really no recovery from a file that you don't have permission to read from. So there's one instance in which exit, be done. Right? All right, so I read every single character, and you see 1, 2, 3, 4, 5, 6, 7, 8, 9. Why are there gaps? Spaces, certainly, but also end-line characters. Right? End-line characters. It reads those end-line characters, and it preserves them. If you don't want them, if you don't want to print them, then you need to take care of that. Right? But there is a very simple loop for reading an entire file, character by character, all the way to the end. Right? So, let's see. There we go. Forgets is a little bit different. Instead of going one character at a time, you can go an entire string or an entire line of code, a line of the file at a time. It reads up, it reads all the way until it sees that first end line character, the /n. Not a null terminating character. There are no null terminating characters in a file. That is a C thing. That is a C string thing, right? Here is the full signature of this function. Right? It takes a string, and by the way, is that a const string? Nope. So what do you think it's going to do? Is it going to just read from that string? Nope. It's going to actually write to the string. That's where it's going to put the contents of that file, that line. Right? Size is a way of preventing buffer overflows. I'm going to tell it don't write past the string. If this string is 100 characters, I'm going to say read at most 100 minus 1 characters so that you don't overflow this buffer over here. Why not size minus 1? Why 99 minus, or 100 minus 1, 99? What's that minus 1 for? The null terminating character at the end. Right? It puts it in there automatically for you. And then finally, this is the file that you're reading from. Okay? So S is the string, or sometimes we just call it a buffer, etc. Yeah, go ahead.
So why are we returning a car if we're keeping that string itself?
Good question. It doesn't use EOF because EOF is a character. It uses the return value to tell you that's the end of the file. Right? So again, S is basically the buffer that you are reading into. Size means that you are limiting the number of bytes that it reads. It'll try to read all the way to the end of the line. If it sees the end of the line, it's done. It stops. And whether or not it preserves that end line character, we'll find out through experiment here. But otherwise, it will. If it doesn't get all the way to the end of the line, it will read at most size minus 1 bytes in order to accommodate that null terminating character, which it takes care of for you. Okay. Again, it stops when it first sees that first end line character, or reads at most size minus 1 bytes. The last argument, of course, is the file pointer that you are reading from. And here's the answer to your question. Upon success, it returns a valid pointer to the resulting string. So you're right. S and the pointer that it returns are the same thing if it's successful. If it's not successful, they're different. What could it return when it's not successful? You read all the way to the end of the line, or end of the file, excuse me. Right? What can it return? What's the only thing it can return to tell you that it reached the end of the file? EOF is a character, and we've got a char star here, so null, right? So I need to spell pointer correct, right? At the end of the file, it returns null, right? Whatever was still in S is still there. It just the return type is what you use to determine it didn't read anything because there was nothing left to read. Right? Yeah. Nope, it is /n. So it's the end of line character, it's /n. The null terminating character is /0, and those are not the same thing. All right, so let's do the same thing that we did before. Read the entire file, but instead of character by character, we'll read it line by line. Typically what you do is you create a buffer that is big enough to hold any reasonably sized line. So I'm going to go ahead and create a character buffer here. In fact, I'll even call it buffer of, say, I don't know, 10,000 characters. Right? That's a static declaration, meaning that it is on the stack. Does it matter here? Is 10,000 too big? No, that's only 40K, or less than 40K. Right? If I did, say, 10,000, 100,000, 1 million, 10 million, oh yeah, that's too big. So if you're going to read very, very long lines, files where there's lines that are 10 megabytes, rethink what you're doing first of all, because that sounds stupid. You're probably doing binary data at that point, in which case you bring in a library to do it for you. But you don't want long lines there. Right? 1,000, 10,000, whatever. Okay? That's my buffer. Okay? Now what I want is a char S in order to keep track of line, next line, next line, next line, until that reaches null, the end of the file, in which case it's null. That's going to be my, my indication that I'm at the end of the file. Let's call the gets. Remember, it takes 3 things. What are those 3 things? The buffer that you want to read into, the size of the buffer, -1, right? You don't have to do the -1 yourself, and then the stream that you're reading from. So the buffer that I want to read into is buffer. It's at most 10,000 bytes, minus 1 for the null terminating character, and the file that I'm reading from is f. Let's print that out, and then we'll write our loop to do the rest of it. So printf. Now I've got an entire string, all right? Buffer is equal to %s and the line, and buffer. And let's run it, and you'll see that it reads that first. It opened the file successfully. Buffer is equal to hello world. And that was the first line in this file.txt. Why is there a space? Why is there a blank line right here? I printed the end line character here, but also there was an end line character in the original file. And that's why I've got 2 end line characters. So note, forgets, preserves the end line character. End line character. And the end line character is /n. Okay? If you don't want it, you can chomp it out. So another appropriated word here, clobber and chomp. Chomp simply means to take out the trailing white space. If there are 50 end-line characters or 10 spaces and then an end-line character, chomping all of those out takes out all the end-line characters. Right? And to do that, all you need to do is set the end-line character /n to a null terminating character /0. And we'll do that here in our exercise. All right, how do I write a loop to do this? This will be, forgets returns null when it gets to the end of the file. So if I kept doing this over and over and over again, of course I won't redeclare it, I would get line, 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 line. I don't know how many lines there were. Let's just go like this. Okay. Oops, and then run it. That last line got printed twice there. Why? Because once it reached the end of the file, it returned null, but whatever was still in that buffer is still there. Right? So let's go ahead and get rid of this stuff, and let's rethink this as a loop, a while loop. While some condition, print out whatever's in the buffer, and then set yourself up for the next iteration. Right? While what? S is not null. Keep going. Once S hits null, that's the end of the file. There we go. And now it only prints once at the end. And again, I'm getting all these spaces because I'm both printing the end line character and it preserves the end line character. If I just don't print the end line character here, of course it'll print the end line character that's in the file. If I want to chomp it out, chomp. Suggestions? I want to take out that end line character at the end of the buffer. Buffer of something is equal to the null terminating character instead. What is that something? 5. strlen of buffer or S, since they're the same thing. Right? Now let's think about this. HELLO, end line character. Right? How many is that? 6. 0, 1, 2, 3, 4, 5. So -1. And note here I've restored the printing of the end line character here, so it should give me the same thing. Oops. What's wrong? Say what? Well, chomp is just what it's called. There's not a function called chomp. You could write a function called chomp, I guess. Buffer. Oh. Should you print it and then chomp it, or should you chomp it and then print it? Chomp it, then print it. There we go. All right. I will put this in the notes so that you have this as well. Ah, come on. There we go. All right. Yeah, go ahead.
So how does setting the last character for the null terminating
Well, it's just taking out you're right, it's not taking out all trailing white space. It's only taking out that last character, which I know to be an endline character. If you wanted to be absolutely sure, you could, of course, say if what's at the end of the buffer is equal to the endline character, then chomp it out. Otherwise, don't chomp it out. Right? I just want to take care of that. I mean, if you've got like 50 spaces at the end, you'd have to set up some sort of a loop that, well, let's do it.
I know, like, in Java, there's like a trim function.
There is a trim there's not a trim function in C. So what you'd have to do is, while is space of, well, here, let's go int I equals strlen of that. We'll start at the end, while the buffer, the ith character is a space, not just the endline character, but any space, tabs, spaces, endline characters, then we'll go ahead and get rid of it. And this should work. Is space is in the C type library. C type library, not sci type library. There we go. And this will have the same behavior, but if I put in the file here, tab, 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 oops, tab, 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 space, 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 space. All right, it's going to take out those spaces because that's the editor doing it. Okay, it's taking out, it's chomping for me in the IDE here, so unfortunately I'm not going to be able to show that, but whatever. But you get the idea here, that you can actually just go ahead and have a while loop here. Start at the end, this is white space, get rid of it. Move, oh, I guess move back. I minus minus, right? Then go back, you start at the end and you go forward. If that's white space, get rid of it by putting in an alternating character. And then keep going forward until you see the first thing that is not a space, and then break out of that. Okay? All right. Questions about file I/O? That's it. fprintf, fgetC, forgets. Right? Open, close. That's it. Five functions will get you everything that you need. And again, if you want to go have a deeper dive, you can go ahead and RTM about, you can RTM about seek. No? Okay. Man, rewind. Oh, it's fseek, of course, right? Because it's file seek. And then rewind, ftell, fget position. It's repositioning a file stream. Fseek, ftell, all these, whatever they do.
There was a set position function, so you can like.
Yeah, you can like jump ahead to the 50th byte or something like that. Sets the file position indicator for the stream pointed to by stream. The new position measured in bytes is obtained by adding the offset, blah, 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 blah. So you can jump forward 50 bytes. You can jump backwards 80 bytes. But just like memory, in memory, if you're going beyond the bounds of a file, it's undefined behavior. All right. I don't have Eclipse open, but we can briefly describe what it looks like in Java. Right. In Java, or Java defines a class called file. And you, just like with Fopen, you can create files. Right. So file F is equal to a new file. You can create one in the current working directory, whatever that means. You can create an absolute path to another file. You can create a relative path to a file. Right? This is basically Fopen. Now, it doesn't technically open the file for reading or writing. It just creates this object that then you can start screwing around with. Right? File input. Right? Lots of ways, but the easiest is something you already know. Scanner. Right? So how did we use scanner before? Scanner S is equal to new scanner scanning the standard or the system.in, right? So that when you mash the keyboard, that's what you're reading from. It's a file. Right? All you have to do, instead of giving it standard in, just give it a different file. Right? So here's a full example. I'm going to go ahead, not Pokemon, but file.txt, because I don't have that file anymore. File.txt, there we go. I open up a file for reading. Writing, it doesn't matter, there's no mode, right? You can do whatever you want. Actually, no, sorry. There's no mode because if you open up a scanner, you are scanning it, you are doing file input. There's no way to do output, right? I'm going to use a try. Scanner, s is equal to new scanner. But instead of system.in, I provide it that file that I created, f. And now everything that you've done up to this point with scanner, you can do with file IO now, right? So while, for example, s.has next line, I can read an entire line. String s is equal to, or string line is equal to s dot next line. Read a line, read a line, read a line, while it still has a line, right? And then print it out or do whatever you need to do with it. System.out.println line. Right. Now, what happens when a file doesn't exist? It will end up throwing a file not found exception. Right? If there are permission issues, I believe it'll still throw the file not found exception. It won't throw a you don't have permission to read this file exception. Right? At least I don't think so. So what do we do in that case? Can you reasonably recover from a file that you intend to read that doesn't exist? Probably not. So we catch and release. We throw a new runtime exception and then not worry about it. Right? Then it becomes a fatal exception unless somebody really wants to catch it. All right?
So when you're catching those exceptions, what's the E that like? Is that just like
That's just the name of the exception. I could call it FNFE. That's a pattern that a lot of people use to file not found exception. Right? I'm just taking that, packaging it up in a unchecked exception so that you're not forced to surround it with a try catch and then throwing it back at you. Right? Catching and releasing. All right. When you are done, while you read a line, you need to make sure that you close it at the end. So s dot close. So open, input as much as you want, close. Exact same steps as C. But instead you use a scanner, you use file, still use dot close, and that's it. Now here is another easier, more modern way of doing this. I'll just go ahead and cut and paste it. No. Here, I'll label it. This is a try with resources. That close, why should I have to do that? Why can't Java do some of my work for me? And so you can. As of Java, I believe 8 or something like that, they introduced this concept of a try with resources. Try this, catch any errors, and then it'll automatically close it for you. By putting scanner in that try inside parentheses right there, it'll take care of the closing of the resource for you. It's very useful if you've only got one resource. If you have multiple files, right, then you open it up, process it, close it. Open it up, process it, close it. But if you try to do that in the same block, then unfortunately you're not going to be able to use this try with resources syntax. Right? Okay. Some notes here.
So
Yeah.
Is the try catch just like a good practice?
Well, it's not. I'd say it's bad practice, but you are forced to do it because the file not found exception is a checked exception. Checked exceptions are ones that you have to surround with a try catch. Try doing this without the try catch, and the compiler won't let you. Right? Again, those are checked exceptions that were introduced into Java from the very beginning. It was a bad idea at the time, and 26 years later, people realize it's such a bad idea that nobody has done it since. C++ introduced it, but it's still optional. Every single Java library to come out since the early days of Java has not used these things. Right? But we're still forced to use it because file I/O was introduced in Java 1, so backwards compatibility, we're stuck with it forever. Going back and changing it is a breaking change, and we don't want that. All right? So some notes here. You can use any number of the next methods. For example, if we just RTM, Java, scanner. If you want to get the next integer, the next object, the next, the next string, etc. Find next. Come on. There. So has next integer, has next boolean, blah, blah, blah. Next integer, next float, next double. Right? I'm just showing you how to do it for an entire line here. Give me the entire line. Whether or not it preserves end-line characters, I think it's different than C, so it doesn't. It'll chomp those out for you. Don't hold me to that, though. Make sure double check by running your own programs. Right? Oh, here it is. White space is used as a delimiter, and delimiters are not preserved in the result, so that end-line character is not going to be in there. You can use has next line or has next to test if you're at the end of the file. And this try with resources relieves you of the need to close it at the end. It'll automatically be done for you. Yeah?
So if the line has like white space at the end of it, it will still take it in?
It'll take it in, but then ignore it, and it won't be in the string. I think certainly not the end-line character, but if it's like 50 spaces, then the end-line character, I don't know. You'd have to run it. And then finally, really quick here, is file output, since it's also so easy. Right? Again, there are many ways. The simplest way is to use a print writer. Right? It allows you to use print, println, printf methods. So let's go into Java mode here and play around with it. So again, I'm going to create a file, f. Sorry. There we go. File f is equal to new file, output.txt or something like that. All right, I don't know why it's not working. Why are you not working? It got a hiccup. No? There you go. Sorry about that. So, I've created a file for output here. And what I'll do is I will use the same try with resources here, because again, it could be a file not found exception if you don't have permission to write to that file. So try with resources, print writer, PW for short, new print writer, passing in the file that you're going to use here that you're actually going to output to. Right? And then you can just start using it. pw.print hello world and the line. Why did I put my own inline character in there? It's not println. If you want to, you can go println. How are you? And that will put in an inline character for you automatically. Or you can use printf style formatting, pw.printf. Here is a number. %d and the line, x. And now again, it could error out with a file not found exception, in which case, if you don't have permission to write to it, is there any reasonable way to recover? Nope, so throw new runtime exception E. There you go. Again, if you use this try with resources syntax, it'll close it for you. Otherwise, if you don't, then you should be doing pw.close. Right? And this is, again, this is not necessary if you use this syntax here. All right, and one last note here. What about binary files? Bring in a library. But in your lab next week, it'll demonstrate how you can do binary I/O. For example, a number. Let's say, I don't know. I'll go down here to the text. 2.147 billion, 1, 2, 3, 1, 2, 3. There. That is enough. That can be stored in an integer, right? If I were to store that in plain text, human readable format, how many bytes would it be if I output that to a file? You would format it as a bunch of characters instead of a number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So it would take you 10 bytes to format that number. How many bytes does it take to represent that number in memory, though? Only 4 bytes. Right? So binary files tend to be way more efficient on space and way more efficient for a computer to read and write. So you'll see that as a demonstration in your lab next week. All right. Any questions? No? Okay. Again, we'll try to have your midterms done by Tuesday, along with Hack 8. And I'll see you next week.